Okay, so as we've previously established, the basic idea, the framework that economists use to understand consumptive decision makings by consumers is this idea of utility maximization. And so far, we've established a number of important concepts and ideas. The most important that I want you to sort of bring forward as we continue our conversation into actual markets is first off the idea of marginal utility. It's going to continually come back up, and we're going to use it as a springboard for many future conversations. And then the second thing that I want you to remember is that at the end of the day, a lot of this is about establishing some notion of rationality. And within this context, the most important bit of rationality that we have is that utility maximization establishes a maximum willingness to pay for a good or a service. So again, what I think or what my experience tells me about how happy a good or service will make me is what informs me as to how much I should be willing to spend for that particular product. We actually see this show up, again, sort of in a fairly straightforward, intuitive way. People often are far more willing to spend money on something they've already consumed versus spending a lot of money on something they have not consumed. In other words, there's risk involved. So if I have my favorite restaurant, I'm willing to spend more at my favorite restaurant as opposed to, say, a restaurant I've never been to before. Some of that's risk, but most of this is, again, that disutility that I may experience by not having an optimal bundle. I want to optimize my utility subject to my budget constraints. So this is often why we end up going back to our favorite restaurants, because why else are they our favorite restaurants? So marginal utility, and then again, just this idea that we're thinking about optimization in the context of consumptive decisions. So on the surface, these are small examples. How much beer and taco do I want to consume? How much scotch and cake and coffee cakes do I want to consume? But the end result is we're discussing market behavior on the consumer side. So a very, very important, very strong, and very straightforward idea that is going to come back and be something that we discuss routinely within the context of markets. Okay, so boom. Law of demand. Law of demand, one of the very few laws in economics, law of diminishing marginal returns, law of demand, law of supply. So very few laws, so that should tell you something. The law of demand just simply tells us that as the price of a good rises, the quantity demanded for that good falls. Notice I did not say that as the price of a good rises, the demand for that good falls. No, and I didn't. I said quantity demand. It's extremely important that we get this out of the way. Demand and quantity demand are two completely different things. Quantity demand is a particular level of demand on a particular demand curve. The demand is the actual curve itself. So real quick, just get that out of the way. Quantity demand refers to the level of quantity demand at a particular price. So at a price of 8 here, 20 boxes of cereal are demanded. At a price of $3.50, 65 boxes of cereal are demanded. Okay. So again, the demand is the entire curve. Quantity demand refers to particular quantity levels from particular prices. So the law of demand just simply tells us that as the price of a product falls, the quantity demand for that product rises, and as the price of a product rises, the quantity demand for that product falls. Very basic. Students get this wrong mostly because they say that as the price of something falls, the demand for it goes up. No. Demand is going to refer to demand increasing or decreasing is going to refer to the shifting of demand up or back. But if we say the quantity demand rises or falls, it means we're moving along the curve. So in other words, if the price of cereal were to change from 8 to 3.50, then we would move along the demand curve down to here. It's not a shift of the curve, it's a movement along. So one of the most important points we need to bring up now is that changes in price, say, of a particular product, do not cause shifts in demand or supply, we'll find out later, of that particular product. In fact, it will be shifts in demand and supply which cause changes in prices, not the opposite. So changes in prices of goods do not cause shifts in the demand for that good. So if the price of cereal were to go down or up, it does not cause a shift of cereal down or up. We simply move along the curve to different levels of quantity demand. Now, we often think about demand in two ways. We think about demand in the context of individual demand. And again, individual demand is going to come from utility functions. It's going to come from maximum willingness to pay. In fact, we'll discuss how the demand curve itself is a representation of maximum willingness to pay. And we can see this if we think about the two types of cereal consumers, people who like cereal and people who love cereal. Notice that people who love cereal have higher demand. Their demand curve is further out. And notice what this means. It means that at the same price, they are willing to consume more cereal than those people who like cereal. So for example, at $3.50, we see that people who like cereal consume 20 units, while people who love cereal consume 45 units. Further, notice that if we just add up these two amounts, we get what the entire market for cereal wants to consume at 3.5 units, which is 65 boxes of cereal, 20 plus 45. Now, what this means is that in order to get the market demand for cereal, I simply add up horizontally my individual demand curves. Now, we've made it a little simpler here. We just have two types of consumers. But if you can imagine that there are a litany of individuals in here with all of their own individual demand curves, and we simply add all those demand curves up horizontally, and it gives us our market demand curve. And so again, we can see that at a price of 8, for example, we would simply take this level of quantity demand for cereal likers, this level of quantity demand for cereal lovers, add those two together, and it would give us our 20 boxes of cereal for the entire market. So the market demand curve is simply an aggregate of individual demand curves. All right, so here's a mathematical representation without the graph. Here I just have a demand function Q equals 100 minus 10p. You actually notice this is the exact demand function I have here. So this demand function here, cereal, which by the way is just the same one as this here, but is this right here, right? 100 minus 10p. I can show you that if I simply plug in values for P, it will spit out levels of quantity demand given this demand function. So for example, if P is equal to $5, 10 times 5 would be 50. So 100 minus 50 would be 50. So if we look at this particular demand curve, if we were to look at a price of $5, we would see that the boxes of cereal demanded at $5 would be 50, as we would predict. Or we could say plug in a price of 3.5, so 3.5. So 100 minus 10 times 3.5 would be 10 times 3.5 is 35. So 100 minus 35 is 65. So Q equals 65. We go back, we can see at 3.5, quantity demand was 65, just as we would predict. So again, we can think about this graphically, or we can think about it in the context of an equation. Either way, it's all basically the same idea. Importantly, the extent that quantity demanded falls relative to price is an important consideration. So in other words, what's the slope, right? So this is one of the reasons why I'm having you consider slopes when we look at linear functions. Because you can imagine that a steep slope or a very flat slope means something in the context of consumers. Given that the demand curve represents maximum willingness to pay, as I've previously mentioned, then having a very steep slope or having a very flat slope for your demand curve must also mean something about the underlying behavior of consumers buying those goods. So think about this in the context of the market for a product like cigarettes, which is addictive, versus, say, the market for tissues, which not only are not addictive, but are not likely purchased by everyone every time they go to the store. So it's a very selective good in that sense, whereas cigarettes are something that when someone who buys cigarettes, they may buy them every single time they go to the store. So I want you to think about what this means in the context of the slopes of the demand curves and what this could mean. Okay, so let's sort of briefly review. The demand curve represents a schedule of prices and quantity demand given a certain level of demand within a market at a given time. It's really important for us to point out that the demand curve is what we call static, It's a snapshot. It tells us at these particular prices what this particular market is demanding. And if anything changes in the market on the supply side or on the demand side, we'll see that the underlying nature of demand itself does not change. Right? At the end of the day, we're always going to assume that demand curves are downward sloping. Price on the vertical axis, quantity on the horizontal axis. Okay, we're going to assume that consumers are utility maximizers. Okay, that's what's going to create market demand, is you have individual consumers all trying to maximize their utility. This creates maximum willingness to pay on the consumer side. So maximum willingness to pay comes from utility maximization, and maximum willingness to pay is what defines the demand curve. Okay, each particular level of quantity demand on a demand curve comes with it a maximum willingness to pay. So in this market, 20 boxes of cereal have a maximum willingness to pay of $8. What this tells us is that if you were to charge $8 for cereal in this market, at most you would expect to sell 20 boxes. If instead you were to sell your boxes of cereal for $3.50 per box, you would expect to sell 65 boxes of cereal if you were the only producer of cereal in that given market. Okay. The other important component about demand is, as I previously mentioned, what would shift the demand curve. And what I mean by this is actually shifting the demand curve to the right or shifting the demand curve to the left. This would be an increase in demand, shifting it out to the right. This would be a decrease in demand, shifting it back into the left. So what shifts the demand curve? Well, essentially there's 5 shifters of demand curves. First, you have tastes or preferences, right? Over time, people consume more of something or less of something because it falls out of favor. Think about the typewriter. We just simply don't need typewriters anymore, so the demand for typewriters has shifted back into the left over time. In fact, way out into the left. Think about computers. Over time, computers now are much more a part of our consumptive process, and so we consume a lot of more computers, so the demand curve for computers has shifted out. Incomes. As people become richer, as people become wealthier, they tend to consume more goods. Those goods, what we would determine as normal goods, if you think back to the previous lecture. So as incomes rise, we expect demand to rise. As incomes fall, we expect demand to fall. So again, if incomes rise, demand rises. If incomes fall, demand falls. Now again, this assumes that the good in question is a normal good. If the good in question is an inferior good, then it would be the exact opposite. As incomes rose, demand would fall, and as incomes fell, demand would rise. But most goods we discuss are normal goods, and so we say they have positive income effects. That is to say that when income rises, demand rises. When income falls, demand falls. The other things that can shift the demand for a product would be prices of complements of that product, or prices of substitutes of that product. Specifically speaking, let's say we're talking about cereal, then let's say that a complement of cereal would be milk, because typically you consume cereal with milk. And so, for example, if the price of milk were to rise, then we might expect people to consume less cereal. So the price of milk may, in fact, cause the demand for cereal to move back into the left. In fact, if the price of a complement good rises, we indeed do think that demand will shift back into the left. On the other hand, if the price of a complement good falls, because those two goods are consumed together, they would expect the demand curve to shift out and to the right. So again, if the price of a complement good rises, demand will fall. If the price of a complement good falls, then demand will rise. On the other hand, if we're talking about substitute goods, so instead of milk, let's say we're thinking about the demand for oatmeal. So for example, let's say that the price of oatmeal were to fall. Since oatmeal and cereal are substitute goods for each other, if the price of oatmeal falls, we may actually expect the demand for cereal to fall, because since the price of a substitute good has fallen, then we would expect people now to consume more oatmeal and less cereal. On the other hand, if the price of oatmeal were to instead rise, we would then expect people to consume more. And so we can generally say that the prices of complement and substitute goods are expected to have impacts on the demand for the complements and substitutes of those goods. So, the price of Coke affects the demand for Pepsi. The price of jelly affects the demand for peanut butter, vice versa. And so, again, these are kind of interesting stories we can tell about the substitutability or complementarity between goods. And lastly, we want to point out that the expected price also has an effect on the demand for a product. So, for example, let's say that I consume cereal and I expect that the cereal is going to become cheaper in the future. I heard news that for whatever reason it became cheaper to produce cereal, and so in the future I expect cereal to become cheaper. What this may in fact cause is for me to shift my demand of cereal back today. And again, remember that the demand curve framework and the supply and demand framework writ large is a snapshot, so sort of in the here and now. We're not looking at sort of time effects here. So let's imagine that I expect cereal to become more expensive in the future, or excuse me, to become cheaper in the future. And so I shift my demand back into the left today. So the demand for cereal will actually fall today. And therefore, I will consume cereal in the future. On the other hand, if I think cereal is going to become more expensive in the future, I may in fact shift my demand to the right of it today to take advantage of the lower prices. Once we get to equilibrium effects, we'll see more about how there are interesting outcomes for shifts. Right now, the shifts are in isolation aren't fairly interesting, but if we have a supply curve here, we can see how shifting the demand curve then would be a lot more interesting. So generally speaking, these are all of our demand shifters. Now there are a lot of sort of ins and outs here. Obviously there are several different complements. There could be several different substitutes and things like that. But when we're thinking about what shifts the demand curve, these are roughly the 5 things that we agree shift the demand curve. And so you should think about not only how these things shift the demand curve, but you should also make sure that you know how to shift them in the right direction. So make sure you look at the lecture notes where I have a nice set of all the different ways in which the demand and supply curves can shift and take you through all of those and what they mean for prices. We haven't gotten to the supply curve yet, but when we do, you'll definitely want to take a look at that.